Hi, ladies and gentlemen. This is Mr. Green. I cannot be with you today for Class Connect because I am giving a STAR test, and so I cannot be with you today, and I apologize about that. So I'm making this recording so that you can get to it and you can listen to it and still uh, hear what we need to be doing. You should be looking at Unit 9. We should be nearing the end of it, and we'll be taking a test on it on Thursday, so that's tomorrow, based upon when this recording will be listened to. And we're looking at confidence intervals and significant testing for proportions and the difference between two proportions. So, looking at this, and that's just in the way. In a recent report, stated that only 20% of all college graduates find work in the field of their undergraduate major. A sample of 400 graduates from across the country found 100 working in their field of their undergraduate major. Does this sample provide evidence at a 5% significance level to indicate percentage given in the report was too low? Well, we're only dealing with one sample here, right? And so this is a one proportion test, not a two proportion test. It's a significance test, so we want to use alpha at 0.05. Okay, so my null hypothesis is going to be that the percentage of 1 is equal to the uh, percent hat. Uh, the expected percentage is equal to, this 20% is equal to what we find. Okay, and the difference here is that it is less than. So we take n at 400, we take x at 100, p hat's at 0.2, p1's at 0.25. How do I get 0.25? Well, 100 working in there out of 400, so that's 0.25. And I use a one-sided z-test with a z-value of 0.25. My probability turns out to be 0.99. Since this p is high, matter of fact, it's very high, there's lots of evidence to reject this and reject the HO and think that the report is reporting too low a percentage. Okay? So we're rejecting the H0 and saying that it's probably a much higher percentage than what the report is reporting. Let's go on. In 1975, a random sample of 1,484 adults in U.S. citizens was surveyed, and 193 agreed strongly with the statement, people should take care of themselves. Then in 1991, a survey of 1,013 adult U.S. citizens showed that only 61 people strongly agreed with that statement. Does this indicate that the proportion of U.S. adult citizens who strongly agree with this given statement, has dropped? Well, we are now looking at two samples. You can see we have a sample in 75 and a sample in 91. So that is a two sample test. Two different proportions that we're going to be looking at. Okay? And it is a one-sided test. Why is it one-sided? Because we're looking to see the strongly agree has dropped. Okay? So my P1 is 0.13. My P2, 0.06. My proportion that's pooled is 0.1. And my N for sample 1, my number for sample 2. Number 1 pooled and N2 pooled, and the N1 times 1 minus the proportion of the pooled number, and N2 times 1 minus the pooled number are all over 10. So we know we're in good shape. Okay? So my standard error is the square root of 0.13 times 0.06 times 1 divided by 1,484 plus 1 divided by 1,013. So my standard error is turning out to be 2.81. So null hypothesis that P2 is equal to P1, that it hasn't dropped. Okay? The alternative hypothesis that P2 is less than P1, that it has dropped. Okay? And we use an alpha level of 0.05. I simply do a calculate two proportions z test. Z is equal to 5.67. My probability here is very, very low. And so since it's so small, there is evidence to support There is not enough evidence to reject the null hypothesis, so that must mean we support the null hypothesis, but that they really haven't dropped any. Okay? Okay. According to the American Academy of Orthopedic Surgeons, 26.6% of all orthopedic treatments are to the knee. Let's assume this report is based on sample data. Compute a 99% confidence interval to the actual proportion of orthopedic treatments to knee under the assumption that the sample estimate is based upon a random sample of 1,000 general orthopedic treatments. Well, what are we looking at here? Once again, there's only one sample being given. And since it is a sample, we're going to do a z interval instead of a t-test. We're going to do a z-test because it is a sample. Okay? And we're going to do a one-sided z-test. So P1 is equal to 0.266. N is 1,000. So X has got to be equal to 266. N times 266, or 0.26, and N times 1 minus 0.266 is greater than 10. Don't have any problem with that. Okay? So my standard error is equal to the square root of 0.26 times 734.734 divided by 1,000, or 0.014. My z value is 2.83, and so when I do that, I get an interval right there of 0.27 to 0.30, or 22.7 to 30. Okay? Since their number falls in that percentage, it's not enough to reject the null hypothesis. And so we would say, yes, so what are we trying to compute at 95 for the actual proportion of orthopedic treatments? So that's the 95% confidence interval for the actual proportion of orthopedic treatments. Hope you guys see how I'm working a couple of these problems, just running through them quickly to make certain you understand them. Okay? Let's do a couple more. Oh. So, I'm sorry. So, very high confidence that the true percentages between the values, both at 1,000 and at the 10,000 level. Note that much tighter range in the 10,000 to be safe to accept. So here's valid. What am I saying there? Oh, I skipped a level here. It's because they said suppose the random sample of 10,000 was used to compute the 95% range. Well, that would change my n value here, but it wouldn't change any of the rest of the values. Okay, my standard error becomes 0.044, and my range becomes 0.025 to 0.0278. And what I'm trying to point out here is 0.0254, and the 0.278 is much tighter than the one that we had up here for 1,000, 227 to 305. Much smaller range there, but it still contains this 26.6%. And so it's safe to accept the percentage as a valid percentage. Okay? So even at 1,000, you were going, I could accept it at 10,000. I'd still accept it, so it's a valid percentage. That's what we're going to go with. Okay, next thing. Crohn's disease is a chronic inflammatory disease. A couple of blind, completely randomized experiments of 71 persons who were resistant to or intolerant to the standard therapy was conducted. There were 37 received cryptosporine and 34 a placebo. Okay? So here's the results here in this table. It says find a 95% confidence interval for the difference between the proportions of those who got better with the cryptosporine compared to the placebo, and interpret the confidence level. This is a two-sample z proportion interval. Because we're asked to find the interval, that's what we're going to do. Okay? My N1 is 37. My P1 is 0.59. Where did I get the 0.59 from? Well, uh, if you add the, let's see here, if you took these and took 22 divided by 37, I believe you get 0.59. My N2 is 34 and my P2 is 0.32. Again, 11 divided by 34. And so when I take N1 times 0.59 and N1 times 1 minus 0.59, do I get something more than 10? And I do. And I also get the same thing when I'm doing it for 2. So I can proceed with this. My standard error is 1.96 times the square root of all this information. Because my sample sizes were different, I have to use this formula. Remember, the percentage times 0.41 divided by 37. Oh, that's P times 1 minus P divided by 37 plus P times 1 minus P divided by 34. Adding those together, I get 0.223. Okay, so my interval is between 0.59 and 0.32, plus or minus 0.23, and so that's 0.47 to 0.93. Oh, my interval difference here. So I took the 0.59, subtracted the 32, okay, plus or minus the 0.223, and that's what gives me this 0.047 to 4.93. You notice 0 is not in that range. So since there's no 0 in this range here, we would assume that there is a difference between the two. And so you would say there is my confidence interval doesn't contain 0, so it's safe to conclude that there is a difference between the clostofluorine and the placebo in this situation. Okay. Well, that's all I really have got for you. I just wanted to work through these problems real quickly, show you how we're doing them, showing you that one sample test, two sample tests, they all work about the same. Okay, confidence intervals, or hypothesis testing, they work the same no matter what we're doing there. Okay, it's just a matter of getting used to doing them and doing them over and over until you start getting the handle on them. Okay. Okay. Well, I'm going to stop the recording and I will see you next week.